Good morning. Happy Thursday. We are nearly to a nice 3-day weekend, which I'm sure everyone can enjoy. Actually, I have to be here at school, so you're welcome, but you can have the day off. So yesterday we talked about inequalities, solving inequalities, what that looked like, graphing them on a number line. Today, we're going to look at, it's very similar, but they're called compound inequalities. So compound inequalities, you might have an idea. Means that there's like two things going on, right? So what we're going to have is two types of compound inequalities that we could have happen here. So the first example would be something we're just going to call them OR compound inequalities. So for example, I might say 5x plus 7 is less than 13, or negative 4x plus 3 is greater than 11. Now you might think to yourself, Mr. Odie, why would I ever need what would be the purpose of a compound inequality? Why would we have that? That's a really good question. So sometimes things need to be capped on both sides. So think of Cedar Point. You guys have probably been to Cedar Point. You can't ride the Maverick unless you're 48 inches tall, right? So you need to be greater than 48 inches. But it has shoulder harnesses that are set. So some of you might not know this. I'm a pretty tall dude, so I know this. Some rides at Cedar Point, I'm too tall to ride. So my body goes over the length of the allowable with the shoulder harness, and it wouldn't properly fit. Usually it's about 6'6". So you have to be less than, what's that, 60, 72, 78 inches tall. So that's an OR inequality. You have to be greater than 48, or, I guess it would be, actually that's the next one we're going to talk about, and less than 78 inches. So there's a lot of things that are capped that way, where there's a minimum and a maximum. Those are kind of the ideas of a compound inequality. So if we're solving this thing, the OR ones are pretty easy. Basically all that's happening here is we're going to solve both sides of this thing. So over here, if I want to get x by itself, we're going to subtract 7. That gives me 5x is less than 6, right? And then divide by 5, and x is less than 6/5. So I know that whatever is going on here, I know x has to be less than 6/5. Or whatever happens on this side. So now I'm just going to solve what's going on over there. So I'm going to subtract 3. That gives me negative 4x is greater than 8. And then divide by negative 4. Careful, if we divide by negative 4, that means we got to flip our inequality. And that would be negative 2. So what's going on here is either this thing has to be less than 6/5, or it has to be less than negative 2. So now we graph it on the number line. Same idea as before. Only now we have two things to graph, right? So you might need a longer number line. These ones are pretty close together. This is a little bit more than 1, so maybe we'll start at like 0. 1, 2, negative 1, negative 2. And we need at least 1 on the other side, so we'll go negative 3. So let's take a look at what this will look like. X is less than 6/5. Well, 6/5 is, like I said, over here. It's less than without the equal sign. So that's going to be an open circle. And let's see, pick a number. 1 is 1 less than 6/5? Yes, it is. So that's going to shade this side. Now I'm not going to shade it yet, and you'll see why. Because I want to do this one first, and then we'll talk about shading. So x is less than -2. So here's -2. It's a strictly less than sign. So that's going to be an open circle at -2. And again, just checking, -3 is smaller than -2. So that one's also going to shade this side. So here's what happens in this case. They're both going to shade to the left, which means it's going to look just like one of the old ones. We don't even need this circle because that -2 is included in this side. So basically what's going on here is all the numbers that are less than 6/5 are going to be a solution set here because it's either less than 6/5 or less than -2. But all the stuff less than -2 is also less than 6/5. That's one thing that could happen. Let's look at another thing that could happen, and you can see the difference here. All right, let's say we have I'm trying to use one from the book. I'll just make one up. Let's go. -2x plus 5 is greater than, what's it greater than? 13. Or, 5x plus 2 is greater than or equal to 17. Yeah, that'll work just fine. So, again, I see this or, so I got two things going on. So what am I going to do? I'm going to solve both. So when I solve both, I'll start over here. I like to just do one at a time. I've seen people who do like the first step on both and then the second step on both. Whatever works for you guys. You guys got to figure that out. But I like to just do one at a time, like I'm doing the problem, then do the next one. So I'm going to -5 from both sides. That's just going to be -2x is greater than, and that's going to be 8. And then divide by -2. Again, be careful. We divided by a negative, so we need to flip my inequality. That'd be -4. And then I'm going to solve this side on the right here. So I'm going to -2 on this one. That gives me 5x is greater than or equal to 15. And then divide by 5. And we got x is greater than or equal to. We don't need to flip it because it's positive. And that'd be 3. So we have x is less than -4 or x is greater than or equal to +3. So again, my number line needs to include numbers on both sides of those numbers. So we're going to start with -5, it looks like. And go -4, -3, -2, -1. I didn't make this big enough. 0, 1, 2, 3, 4. There we go. So, what's going to happen here? Well, I'm going to do one at a time. X is less than -4. So less than means an open circle, because there's not a line underneath it. There's no equal to. So find -4. Here's my open circle. And which side would this shade? Is -5 less than -4, or is -3 less than -4? Well, -5 is smaller. So this is going to go this way. I'm just going to leave it like that for now, just to kind of remind me. I would recommend, I usually don't do this, but I would recommend pencil, because if you do little, like you could do little arrows or something or anything just to remind you which way it's going, and then you can like erase it when you're done. That might help you. And then over here we have a closed circle because we have that equal to sign. So I find 3 and I get this colored in circle. And I check which side is true. Is 2 bigger than 3? Not. 4 bigger than 3? Yes. So this side is going to shade this way. So this time, we're going opposite directions, right? So you can go ahead and shade. This one's going this way. And this one is going this way. So it looks like for a number to be a solution here, you have to be less than -4 or greater than or equal to 3. Either one would be a solution. So either one would work because it's going to be in a shaded region on our number line. The only numbers we can't get are in between here, basically from -4 to 3, not quite 3, right before 3. Okay, let me show you an and one and then I'll be done. Because, yeah, the bell's going to ring soon and I got to teach another class. So, and is the same idea, only they both have to be true. So it's a little different. On or, one or the other, it doesn't matter. But on and, it does matter. So, something like -12 is less than or equal to 7x plus 9. And 7x plus 9 is less than 16. Now this one happens to have some of the same numbers on each side. That's fine. Oh. Yeah. So we got this going on. It has to be 1. It has to be both of them to be true. So, same idea, we're just gonna solve both, okay? So over here, we're gonna minus 9. That's gonna give me -21 is less than or equal to 7x. We're gonna divide by 7. And x is not gonna flip our inequality, and that would be -3. So part of our equation, or our inequality, it has to be greater than -3. All right. What else does it need to be? Well, if I minus 9, 7x is less than 7. Divide by 7. We don't have to flip it because it's positive. So x is less than 1. So in this case, it has to be greater than -3 and less than 1. So what's that going to look like, Mr. Odie? Good question. Start with -4, -3, -2, -1, 0, 1, 2. So I have 1 at least on either side of those. This circle over here is going to be closed because it has that line underneath, so it's equal to. This one over here is going to be open. And then let's see. Is -3 less than -4? Nope. Is -3 less than -2? Yep, this is going this way. X is less than 1, 0 is less than 1, that's true. This is going this way. So in this one, and this is what you're going to have on and, typically, is we have a solution. These are the only numbers that are going to be true in both of these sentences up here. If you plugged in 0, that's a really easy one to see. Sometimes 0 is 0, plus 9 is 9, -12 is less than 9. That's true. Sometimes 0 is 0, plus 9 is 9, 9 is less than 16. That's true. These numbers that are shaded in here are the only numbers that will be true in both. And that's important because it's the and that's going on here. Okay? I think that's pretty much it. I mean, I don't want these. I'm trying to keep them under 15 minutes. I'm at 14 something, so that was pretty close. Try out your homework. You guys, make sure you're letting me know if you guys are struggling, okay? I know you might seem weak and we don't know each other that well. That's okay. Like, I love helping people learn math. That's my favorite thing. So please email me, send me a reminder. If you need help at any time you get stuck on one, send it to me. And as soon as I can, I will totally get back to you, okay? All right. Hey, Thursday, that means Friday's tomorrow. Something to look forward to. See you later.